Good morning, guys. We're going to go ahead and get started with lesson 25. Today's lesson objective tells us I can write a fraction and a decimal as a percent of a whole quantity and write a percent of a whole quantity as a fraction or a decimal. So what we're going to be doing is converting fractions, decimals, and percents to each other. So sometimes they'll give us a fraction and tell us to convert it to a percent, or they'll give us a decimal and tell us to convert it to a percent, or they'll give us a fraction and tell us to convert it to a decimal. Okay, so let's go ahead and get started. Example 2 says a survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part-to-whole fraction for comparing happy participants to the whole. Then write a part-to-part or part-to-whole fraction of the unhappy participants to the whole. What percent were happy with their job and what percent were unhappy with their job? So the first fraction they want us to give is the fraction for the happy participants. Okay, there were 700 happy participants, so I'm going to put 700 as the numerator. But how am I going to figure out what goes on the bottom? Well, I need to see how many there were total. There's 700 here and 300 there, which gives us 1,000. Okay, now to figure out the percentage of 700 over 1,000, we have to put it over 100. Okay, so we divide 1,000 by 10, so we have to do that to the top as well. 700 divided by 10 is 70. 70 over 100 equals 70%. Okay, now let's look at the unhappy. We know we have 1,000 people total. The unhappy participants were 300 of those 1,000. Okay, we're going to divide both by 10 to put it over 100. And 300 divided by 10 is 30. 30 over 100 is equal to 30%. Okay, and at the bottom, be sure we do this. We can scale up or scale down to get 100 as the denominator. Okay, because remember, percentage is always out of 100. Sometimes we may have to scale down like we did here by dividing, and sometimes we're going to have to scale up. Okay, let's go ahead and move on. Complete the exercise with a partner or independently. Renita claims that a score of 80% means that she answered 4/5 of the problems correctly. She drew the following picture to support her claim. So she has 4 rows highlighted out of 5. There are 20 in each row. So that's 80 over 100. Okay. Renita is correct because 4/5. To get this over 100, we would multiply this by 20. I'd multiply 4 by 20, which gives me 80. So 4/5 is equal to 80%. Okay, how could you change Renita's picture to make it easier for Renita to see why she is correct or not? Well, this diagram was long ways and only had 5 rows. We could make a 10 by 10 grid, which would make a better visual. Okay, let's go ahead and keep going. Exercise 2 says use the diagram to answer the following questions. Okay, at the top, we see that the diagram's cut into 5 equal pieces. Each piece is 20% to add up to 100. So 80% is what fraction of the whole quantity? I find 80% there at 4/5. Okay, 1/5 is what percent of the whole quantity? I find 1/5 there, and that is 20%. 50% is what fraction of the whole quantity? This is where it gets a little bit tricky. 50% of this tape diagram would be somewhere here, okay? And it would be at 2.5 or 2.5. So our fraction would be 2.5 over 5. And then 1, the whole number 1 is what percent of the whole quantity? Well, we're not talking about 1/5. Okay, we're talking about 1, which means 5/5 is equal to 1. So 1 would be 100% of the whole quantity, because it is the whole quantity. Okay? Let's go ahead and move on. Exercise 3 says Maria has completed 3/4 of her workday. Create a model that represents the percent of the workday Maria has worked. Okay, so I'm going to make a tape diagram with 4 equal parts because it's 3/4, and I'm going to have to shade 3 of those. So I'm going to shade 3/4 real quick, and there's my model. Okay, now the first question is asking, what percent of her workday does she have left? Well, this is the workday she has left, which is 1/4, and 1/4 is equal to 25 over 100, which equals 25%. And we just multiplied 4 by 25 and 1 by 25. And how does your model prove that your answer is correct? Well, 3/4 would be equal to 75%, because 4 times 25 is 100, so 3 times 25 is 75, and 1/4 is equal to 25 over 100, which equals 25. And this would equal 75%. All right. Let's go ahead and move on. So this problem is a little tricky, so please follow along and pay attention. Matthew completed 5/8 of his workday. What decimal would also describe the portion of the workday he has finished? So I have the fraction 5/8. Well, 8 does not go into 100 evenly, so we cannot do that. Okay? What we have to do in situations where the denominator does not go into 100, what we have to do is divide. This fraction turns into a division problem. Okay, so we're going to divide 5 by 8. So I have this, and I know that 8 is bigger than 5, so I'm going to have to add a decimal, and I'm going to add 2 zeros to begin with. We might need more. Okay, I'm going to bring my decimal straight up and add a 0 because 8 does not go into 5. And then now we can divide. 8 goes into 56 times. That's 48. We subtract this and get 2. We bring down the 0. 8 goes into 20 twice. That's 16. We subtract that and get 4. I'm going to add one more 0, bring it down. 8 goes into 40 5 times. And that's our answer. So the decimal that describes the portion of the workday he has finished is 625 thousandths. Okay? Now, this is where it also gets tricky. How can you use the decimal to get the percent of the workday Matthew has completed? So I have 0.625, which is 625 thousandths. As a fraction, that would be 625 over 1,000. Now we can divide to get it, we can scale down to get it over 100. So I'm dividing 1,000 by 10, so I need to divide 625 by 10. 625 divided by 10, 6, 2, 25 left over. I'm going to add a decimal and a 0.5. So our fraction turns into 62.5, which is 62.5%. Okay, another trick is whenever you divide something by 10, the imaginary decimal at the end is always moved to the left, so it would just be 62.5. Okay, let's go ahead and move on. Okay, so exercise 5 says complete the conversions from fractions to decimals to percent. So I have 1/8. I want you real quickly to pause the video and try converting 1/8 to a decimal and to a percentage. I am going to tell you 8 does not go into 100 evenly, so you need to divide. Okay, guys, you should have paused the video, and we are now going to go over these together. 1/8, when you would have divided 1 by 8 and added 3 zeros, when you go through this, you would have gotten 0.125 or 125 thousandths. So that is our decimal, and our percent would be 12.5%. Okay? Now, 35 hundredths as a fraction is exactly how it sounds, 35 hundredths, and as a percentage, it is 35%. Okay, now we have 84.5%. As a decimal, that would be 0.845 or 845 thousandths. And as a fraction, this could be 84.5 over 100 or 845 over 1,000. Okay? Now, 325 thousandths. As a fraction, this would be 32.5 over 100 or 325 over 1,000. Okay? And as a percentage, this would be 32.5%. So the last one, 2/25ths, all we have to do is round up or scale up. This is times 4, so we have to multiply 2 times 4, which gives us 8 hundredths. So this, as a decimal, would be 8 hundredths. Remember, the 8 is in the hundredths place, so we had to put a 0 in the tenths place. And as a percentage, this would be 8%. Okay, let's keep on going to the lesson summary. The lesson summary tells us fractions, decimals, and percentages are all related. To change a fraction to a percent, you can scale up or scale down so that 100 is in the denominator. So they give an example here. They have 9/20ths. They realize 20 goes into 100 5 times, so you have to do that to the top as well. Then you get 45 over 100, which equals 45%. Okay? Now, there may be times when it's more beneficial to convert a fraction to a percent by first writing the fraction in decimal form. So we have 5/8. We've described in this lesson that 8 does not go into 100 evenly, so they had to divide 5 by 8. They would have gotten 6.625 like we did earlier, and we know that this would equal 62.5%. Models like tape diagrams and number lines can also be used to model the relationship. The diagram shows that 20 over 80 equals 25%. So here, the model's cut into 4 equal pieces. Each piece is equal to 25%, okay, out of 80. Okay, so we're going to do the problem set together. Please do this on your own first, and then check with me or check the video for the answer. So pause the video, go do the problem set real quick, and then we will go over it together. So it says use the 10 by 10 grid to express the fraction 11/20ths as a percent. So I have 11/20ths, okay? I need to show this on the 10 by 10 grid, which has 100. So we have to put this over 100 and scale up. 20 times 5 equals 100, so we have to do 11 times 5, which equals 55. Now I know how many boxes I need to shade. I need to shade 55 boxes. So I've done that real quick. I have 55 over 100 shaded on the graph, which equals 55%. It says use a tape diagram to relate the fraction 11/20ths to a percent. So I'm going to make a double tape diagram. I'm going to cut it in half. Then I'm going to cut it into 10 pieces. Then I'm going to shade 11 of those 20 pieces. And then now we are complete. So how are those diagrams related? Well, this is 11 over 20. This is 55 over 100, okay, which they both equal 55%. Okay, so we would put both are 55%. What decimal is also related to the fraction? 0.55 55 hundredths equals 55 hundredths. Okay. Which diagram is most helpful for converting the fraction to a decimal? Well, I like the 10 by 10 grid because it gives us 55 over 100 already. It's over 100, so I know that I have to put 55 in the hundreds place. All right, guys, if you are confused, please watch the video again and ask some questions on Google Classroom. Make sure you tried this problem set on your own first, okay? And have a great